Hey, welcome to this video. In here we're going to talk about the least squares regression line, also called as LSRL. So this is basically means the line of best fit for the line that best fit for the data. One more try. Okay, so here is the scatter plot that we constructed from last video, and how do we interpret it? Well, according to the pattern and trend of the data that's showing here, we can say that this is pretty strong, positive, and linear relationship between the number of boats in Florida and the number of mentee deaths. A little bit recap from last video. So let's go into the main topic right here. So first, interpret the correlation coefficient R in the context of the problem. We know the R right here, this is the value, but what does it mean? How are we going to interpret it? First of all, this value is positive, which means there's a positive association. Also, because it's pretty close to 1, right? 0.947. So we can say that it's having a strong relationship. And also because it's linear relationship, right? Between number of boats and mentee deaths. And AP tip right here, a common question is, what is the equation of LSRL? It's pretty much like y equals ax plus b. Instead, the b will be negative 40.64, which is like basically you can get this value from the data, and this is our a value. So LSRL is the least squares regressions line, and this is the line of best fit right here. So basically, like y hat. The reason that we put a y hat right here, because this is our predict equation. It's not a actual equation. The raw data that we constructed is all of those dots in the screen, but the line of the best fit is LSRL, which you can see that it's kind of in between most of the data, and that's good. And another question you'll be frequently asked is, interpret the slope of the line in context. We know b is equal to 0.125, so we're going to say for every additional 1,000 boats, the predicted number of mentee deaths will go up 0.125. Interpret the y-intercept in context. We know a is equal to negative 40.64, so we're going to say for 0 boats, the predicted number of mentee deaths is negative 40.64. This is extrapolation and doesn't make sense. So because, think about it, we get this value right here, but if we're gonna really put it into real life, there cannot be a negative number of deaths. So it doesn't make sense, which means there's maybe some extrapolations current in here. So what does extrapolation mean? So extrapolation is predict outside range of data. For example, we just want data from A to B, but somehow we predict the data from B to C, and C is not in the range from A to B, which means there's some extrapolation occurring. Interpolation, on the other hand, is kind of opposite with extrapolation. It predicts within range of data, and this is good. That's what we want. We want interpolation, not extrapolation. But sometimes it's unavoidable, so you're just gonna state that in your conclusion, and the grader will know. Key facts about the LSRL that you must know is, first, goal is to use LSRL to predict. Remember, this is a very important term, and X bar and Y bar is always online, which means that if you want to grab a coordinates value, you're gonna grab a coordinates value from the line that we created, the line of best fit. Third condition is average observation predicted is the residual. Like observation minus predicted value gives you the residual, which is 0. And if you want to see it from here, like the distance from the dot to the line of best fit is the residual for each individual dot. And what we want right here is to find the average of those residuals, which will essentially be 0. if the line is really the line of best fit. Fourth condition is b equal to r times s sub y divided by s sub x. So the standard deviation of y values from y-axis divided by the standard deviation of x values. A is also equal to y bar minus b times x bar. Those are the formulas that provided on your brochure from AP Stats Test Center. So be sure to find like where are those so you can quickly find those in your exam. Okay, another thing is what is r squared that appears on the calculator? It is called the coefficient of determination. Remember in the last video we just discovered what is the correlation coefficient, right? That's r. The r squared is the coefficient of determination. So it has a very specific interpretation. And coefficient of variation is percent variation, also called as percent variation. So just think about like the graph right here from x sub 1 to x sub 2. In the range that we want to find the difference between the observed data minus the predicted data, which gives you the residual. R squared is the percent of variation that can be predicted by changes in x using this model. R squared, in this case that we're doing with, is going to be 89.7%. How do we interpret it? It's going to be 89.7% of the variation in the number deaths of mentees can be explained by this model. So some of the questions will asking you, does this model work? You're gonna check with two ways. You can approach it with two ways. One is the r squared. If you say r squared right here, you'll be good. And another is provide the residual plot. But wait a sec. You know what? You have to provide both of these conditions. You cannot choose one of them to provide. You have to provide both of them. So you have to also mention the residual plot. R squared is 100%, and residual plot is basically the graph right here we just did. Yeah, and we will talk about all of those in the next video more in depth. This video's focus is basically the introduction of LSRL, least squares regressions line. You will see what does it look like, how do we interpret it, and in most of the cases it will ask you a bunch of questions related to this LSRL. So what you're gonna do is really make sure the format of answering those questions and you'll be good. One last thing I want to mention is R squared is always between 0% to 100%, right? So if this is a perfect line of best fit, then R squared will be 100%. So you can see that. You can also use this value to mention like to determine how do you want to interpret this, because in this case we get a 89.7%, which is pretty good. We have a pretty high R squared value, coefficient of determination. So the variation in the number of incoming. So yeah, so this model is pretty good. Yeah. So like more far off your R squared value be, the less variation you can cover from this model to the real data set. Yeah, so basically that's it all for this video. I hope you learned something from it. Thank you so much for watching. If you have any questions, please leave comments below, and good luck on your AP exam.